Blockchain technology has many amazing applications and opens up the door for a straightforward consensus mechanism where the data structure itself enables very simple checksumming. But this simplicity could also be seen as its downfall. Why? A blockchain is exactly what it sounds like, an ever-growing chain of checksummed blocks that grow indefinitely. There are a few problems with this simple but ever-expanding setup. Constantly growing memory consumption. For rapid lookups of blocks on the blockchain, a lookup table is traditionally required in memory. Constantly growing storage space usage. Blocks are continuously created, causing stale and no longer relevant blocks to be left behind and stored on disk forever. Massive resource waste. At the time of writing, in June 2021, there are roughly 80,000 Bitcoin nodes storing 351.19 gigabytes of blockchain data on each node. That compounds to about 27,436 terabytes. This is for a relatively small blockchain such as Bitcoin. With heavier blockchains, the problem quickly becomes more severe. Limited number of transactions per second. To prevent the data stored in blockchains from growing to absurd sizes, there's usually a limit to the number of blocks that can be created and their size. Transaction fees are used to limit the creation of new transactions and to prevent the chain from becoming overly congested. These are the main reasons that blockchains are limited to the amount of transactions per second they can handle. Bitcoin can only handle roughly 7 transactions per second. Some projects have ramped this up to hundreds or thousands of transactions. However, when actually tested in production, they often fall short of their theoretical limits. These limitations are an obvious and big problem, and is one of the reasons for the original development and inception of the Unigrid network. So this is the problem. How do you store massive amounts of data and keep track of it? Simultaneously, how do you allow the network to grow without major bottlenecks and performance problems forming as it does? The Unigrid network approaches this problem differently. The Unigrid network isn't a single ledger or blockchain. Instead, it's a collection of blockchains with data striped across them with parity blocks introduced for fault tolerance and redundancy. The end result is a network where the amount of transactions that can be handled borders on the infinite. The number of transactions the network can handle grows as the network does. Picture it like this. Imagine the Unigrid network as a collection of smaller networks that are independent from each other. In the middle of this, an address tree ledger is used to keep track of the network and how to find the data. To limit resource waste, the Unigrid network, with the help of the address tree ledger, also allows blockchains to reorganize and throw away stale blocks. Preserving balances, transaction blocks, and data blocks that are no longer valid or simply too old to matter are thrown away. This allows the storage space used on the network to grow or even shrink in size. This makes Unigrid the first blockchain network that can size adjust and segment itself in this manner. This optimizes resource use and allows the network to load balance itself by placing nodes into segments that need to be able to handle increases in traffic. To learn more about the Unigrid network, please visit the About section at the Unigrid Foundation website.